Okay, good morning, everybody. Hope you guys are doing well. So, today I am going to continue to discuss graphical solutions to systems. In our last discussion, we talked about systems of linear equations, which is something that you did cover in Algebra 2 as well. And so, just as a refresher, a system of linear equations is more than one linear equation graphed on a coordinate plane. And then your goal to graphing these systems on the same coordinate plane is to find the point of intersection. Today, we're going to look at something more than just linear systems of linear equations. So you can see right here, it says, notice from example 3 that a system of two linear equations in two unknowns can have exactly one solution, more than one solution, or no solution. And I talked about this in the last time that I posted the video for the first section, is that there are three things that can happen whenever you graph two lines. And now it does say, in which I'm going to show you a picture of in a second. Now it does say by using a graphical method, you can gain insight about the number of solutions and the locations of the solution or solutions of a system of equations by graphing each of the equations in the same coordinate plane. And just as a point of note, the solution to a system is a point or points of intersection of everything that is graphed. So here is an example of different systems. The first one being a system of linear equations. So if you're looking here, those are two linear equations that were graphed, and you can see that they intersect right there at that point 2, 0. And that point 2, 0 is considered the solution to the system of equations. Now, in the second one that you see right here, we have a parabola and a line. Okay, so this would not be a system of linear equations. This would be a system of nonlinear equations, and this is what we're going to begin to talk about. This is where what we discuss in Algebra 3 is beyond what you talked about in Algebra 2. In Algebra 2, you just dealt with linear systems. Now we're going to talk about nonlinear systems. And you can see that with this parabola being crossed by a line, there's actually 2 points of intersection. There's this point right here, which is 0, -1. And then there's this point right here, which is 2, 1. Both of those points are considered solutions to the system. Now, in our third example, right here, that system does not have a solution. So, as I discussed in the last time, if you have two linear graphs that are parallel, there would not be a solution because they don't intersect. The same goes with this nonlinear system in figure 6.3. There is a parabola and there is a line, but they do not intersect. And because they don't intersect, there is no ordered pair that would satisfy both of those equations. So there's no solution. So let's move on to an example. So this is example 2a. And what we have here, you may or may not be familiar with this, especially because of how last year got cut short in Algebra 2. You guys probably didn't get to logarithms, but that right there is called a natural log. And that is a function on your graphing calculator. It's a button. It's called the natural log of x, and that button exists on your graphing calculator, which we'll go into more later. I would not expect you to be able to graph that on your own without a calculator at this point. Later on, we'll talk about that later in the year. And the second equation that we have here is x plus y equals 1. That's just a linear equation in standard form. I showed you how to find the intercepts. When something is in standard form, plug in 0 for x, get your y value. In this case, it would be 1. Then plug a 0 in for y, get your x value. And again, that would be 1. And you can see once I have my x and y intercepts, you can just draw your line down like that. So there's the line that goes along with the linear equation in standard form. But what I want you to see here is where these two things intersect. They intersect right here at that point, 1, 0. And so that point 1, 0 is the solution to both of those equations. So that was a little harder one just because of natural log being an equation that you are not familiar with graphing yet. One thing with graphing that I maybe mentioned in the last video, I want to make sure I mention, it is inherently inaccurate. So it is really important that when you are graphing these, that you are using a straight edge and you're using graph paper to get the best answer that you can possibly get, because it is very, very easy to be off a little bit when you graph your line and then to find the wrong point of intersection. Um, so you can see over here, a way around that is once you do come up with an ordered pair, you should probably plug that ordered pair into each of the equation and make sure you get a true statement. So in the first 1, 0, and 1, 0 in the first equation, they plugged it in, and the natural log of 1 is indeed 0. In the second equation, they plugged the 0.10 in, and you can see they also got a true statement. So they checked the ordered pair in both of the equations, and it worked for both of those equations. So that tells us that our answer that we came up with when we graph them is the actual solution to the system. So let's try one on our own and see if I can do this. And I'm freehanding. Obviously, I don't have graph paper on here, so we're going to do our best. So you can see we have two equations. The first equation is y equals x squared plus x plus 1. I'm going to use orange for that one. And then the other one is the one that you see right below that, x minus y equals -2. And I'm going to use purple for that. So to start, I'm going to draw a coordinate plane, and let's see how straight of a line I can draw here. Hopefully, should be pretty good. Okay, it doesn't look too bad. I'm going to do, I don't know, like 4 hash marks either direction for now. We'll see how far we need to go. We may need to go further in a certain direction. And so let's graph the standard form one. So that's this second one, this linear equation right here. The way we do that is you put a 0 in for the x and the y and get your intercepts. That's the easiest way. So looking here, I'm going to scribble out the minus y. If we put a 0 in for y, we would simply be left with x equals -2, like that. And so x equals -2, I'm going to put a dot right there on -2. Now, doing the same, but this time instead of scribbling out the y, we're going to scribble out the x. You can see that I'm left with -y equals -2, which would mean when you divide both sides by -1, y is 2. And so now that I know y is 2, I'm going to put a dot on there, and then I'm going to draw my line as straight as I possibly can, given the circumstances of how I'm drawing on an iPad freehand. And there's our graph of x minus y equals -2. Okay, so now the second equation, actually the first equation, but the second one we're going to graph is a little bit more difficult. And the reason why it's more difficult is this is going to rely on your knowledge of remembering how to graph a quadratic equation from last year. And this is a bit more involved. So here's how you do it. In order to graph a quadratic equation, you have to find the vertex first so you can find points on either side of the vertex and get a full picture of what the parabola looks like. So in order to find the vertex, you need to use a formula. And that formula is -b over 2a. Okay, -b over 2a. This is to find the vertex, or the x value of the vertex. Okay, so in our equation up here, you can see a is 1. Whoop, that went away. A is 1, b is 1, and c is 1. So we'll need that in a second. But so we need to make a table in order to graph this parabola. But before we make the table, we need to find the vertex. So it's x equals negative, and the b value in our equation is 1, over 2, and then the a value is also 1. So -b over 2a is -1 over 2. So that gets me -1/2. So I'm going to write the value -1/2 in right there. And then I'm going to pick two numbers bigger and then two numbers smaller. So -1/2, then we're going to have 0, 1, and then we're going to go to -1 and -2. So now we've got all of our x values, so we can draw this parabola. Again, keeping in mind, you have to come up with the x value of the vertex. Then you can pick your other x values, two bigger and two smaller of that number that you got for the vertex. And then we need to now get all of the y values over here. And the way that we're going to get those y values is we're going to plug each of the x values in for x in the equation. So remember, I'm gonna circle this for a second. Every one of those x values, each one has to be plugged in to this equation right here for x right there and x right there, so you can get your y value. Now I'm going to spare you all of those details because that's going to, quite frankly, be a lot of work to do that by hand. I'm going to do one of them for you. Um, just because there's a lot of writing involved with that. And I don't have that much room. But if you would go through, if I plug 1 in right here, we're going to start from the top. If I plug 1 in, 1 squared is 1, plus 1 would be 2, plus 1 would be 3. So over in our table, if I plug the number 1 into that equation, I would get 3 out. If I plugged 0 into that equation, 0 for x squared and then 0 for x, I would end up with a 1 right there. Now I'm going to skip the 1/2 for a second because that's the one I'm going to do by hand. If I plugged in negative 1 squared would be 1, and then 1 plus negative 1 would be 0, and 0 plus 1 would be 1. And then when I plug in negative 2 squared is 4, plus negative 2 would be 2, plus 1 is 3. So you can see there's those. Okay, now I am going to do the math for this one right here, for this negative 1/2, so you can see it. So it's going to be y equals, we have negative 1/2 squared plus negative 1/2 plus 1. So negative 1/2 squared is actually 1/4. And then we have minus 1/2 plus 1. I'm going to start by combining these two. So we have negative 1/2 plus 1, which is just 1/2. So this turns into 1/4 plus 1/2. And you've got to get a common denominator. So it would be 4. So you'd have 1/4 plus 2/4, which would give me 3/4. So my value in the last y value is now 3/4. And you can see why I only did that one, because that one was harder because of the fractions. The other ones you could do in your head. All right, so now we have enough points, finally, to be able to graph this parabola. And so we're going to go to 1, 3, right there. I'm going to put a dot. Then I'm going to go to 0, 1 and put a dot. Then I'm going to go to negative 1/2, 3/4 and put a dot right there. Then I'm going to go to negative 1, 1 and put a dot. Actually, I think it would be up there. And then I'm going to go to negative 2, positive 3 and put a dot right there. So you can see roughly what this is going to look like. I'm going to zoom in a little bit so you can see this a little bit better. But we have this point. We got a point here. We got a point here. We got a point there and point there. So as I draw this point right there, and then I connect those, there's my parabola. Now it appears to me that there's 2 points of intersection. It looks like this point right here, and it looks like this point right there. So we need to determine what those are. And that point, the first one would be 1, 3. And then the second one would be negative 1, 1. And right there is what we've been looking for, which are the two ordered pairs. So those two are going to be the solution to our equation. All right, moving on to the last problem that we're going to do. Same idea. We have a parabola and we have a linear equation. And so we're going to graph the linear equation first, and then we'll go back and graph the parabola. Okay, so let's start by graphing the linear equation. Like this. That wasn't very good. 1, 2, 3. That was a little bit more too. And so when I go to graph this, I'm going to go, what color do we want to use? Let's use orange again for this one. Okay, we'll go down 2, and then we would actually going to go down 4 over 2. So I'd have to extend that a little bit further, down 4 over 2. And so down 4, 1, 2, 3, 4 over 2 is right there, roughly. And then we're going to draw a line as best we can right up there. So there's straight through. So now the second equation is going to be a little bit trickier to get um, because it's a parabola, but let's make it happen. So let's use, I don't know, we'll use pink for this one. Going to draw a little bit off to the side. First thing I'm going to do, identify A. A is -3. B is -1. And C is 4. Okay, everybody good there so far? So now what I'm going to do is I'm going to find the x value of the vertex, which is -b over 2 times a. Now that's going to simplify into 1 over -6. So now when I make my table, it's going to be like this. So the vertex, I always like to put a v beside the vertex, is going to be -1/6. Now, so we're going to pick two numbers bigger. I would suggest picking whole numbers, so 0 and 1 bigger. And then I'm going to pick -1 and -2 smaller. Now, to save you all the math, I'm just going to write in what the y values would be. So, whoops. Oh, sorry. Hold on one second, guys. My iPad threw a fit there. So when I plug in 1, you would actually get 0. And when I plug in 0, you would get 4. Okay. Now, when I plug in -1, you would get 2. And when I plug in -2, you would actually get -6. So I'm just going to do the math for this 1/6 one since it's the hard one. So we're going to have y equals -3 times -1/6 minus -1/6 plus 4. So -3 times -1/6 actually becomes +3/6 plus 1/6 plus 4. Okay, so 3/6 plus 1/6 is going to be 4/6 plus 4. 4/6 is 2/3. So this becomes 4 and 2/3. 4 and 2/3. Now again, I got these other y values, these two and these two, by taking these x values and plugging each x value in right there. Okay, that's how you have to get your y's, by taking the x values and plugging them in. Okay, so we have all of our values now. So now it's a matter of just plotting the points and seeing where they intersect. So the first point is 1, 0. The second point is 0, 4. The third point is -1/6, 4 and 2/3. So that's just a little bit more there. Then we have -1, 2. And then the last point is -2, -6, which is way down here. So you can see this one goes like this. Down. Now I'm guesstimating. I want to do this a little bit better. Right there. And then this one comes down like this. Now, I'm guesstimating that it might intersect right there and somewhere in between there. And so the point for this one is to show you that it is really difficult to know for sure where this is crossing. Um, to me, this lower point down here, this looks like -6. So 2, -6. No, that's not even right. because 2, -6 wouldn't work for the linear equation. So, and that's why I'm saying when you find these ordered pairs, unless you actually plug them in, it's really hard to be accurate. So I'm trying to be freehand as much as I can, but you can see that that point to -6 is not even the right point. On the left-hand side, it could be -1, 1, maybe. I don't know. No, that's not going to work because that doesn't even work in the linear equation if you tried over there too. So again, the point to this one, excuse me, the point to this one is that when you're graphing, there's going to be times that you're just not going to know what the ordered pairs are. Here you can see there's 2 points of intersection, but it's going to be very difficult to actually determine what those 2 points are. And so in future videos here, I'm going to be showing you how to get around the inaccuracy of graphing by solving these systems using algebra. So that's what I got for you today. Hopefully that made sense. I will talk to you soon.